Right now, beneath the room you're sitting in, there's a network of pipes waiting for one signal. It comes several times a day. It lasts 4 seconds. And in those 4 seconds, your house performs a small engineering miracle. One that ends at a facility most people will never see and begins with a curve of water you look at every day without ever knowing what it's for. If any single part of this machine fails, it doesn't just stop working, it reverses. This is what really happens after you flush. Look into any toilet and you're looking at standing water. It never drains. That's not leftover water, it's a wall. Every drain in your house leads down to the same underground river of waste, and that river produces gas, methane, hydrogen sulfide, ammonia. The only thing standing between that gas and your bathroom is the water you're looking at. It sits inside an S-shaped curve molded into the porcelain, the trapway. Water can pass through it. Gas cannot, and it isn't just the toilet. Look under any sink and you'll find the same curve in miniature. Showers, washing machines, floor drains. Every fixture in your home hides the same trick. So what happens when you press the handle? 1.5 gallons of water drops from the tank in about 3 seconds, faster than the curve can drain. The trapway floods completely, and the moment it does, it becomes a siphon. That's what a flush actually is. Not pressure, not pumps. A siphon. Pulling everything up and over the curve in one continuous motion. When air finally breaks the siphon, you hear it. That's the gurgle. The bowl refills. The wall of water rebuilds itself. The waste drops into a vertical pipe hidden inside your wall, the drain stack. And this is where the design gets clever, because falling water is dangerous plumbing. A slug of water dropping through a sealed pipe behaves like a plunger. It compresses the air ahead of it and drags a vacuum behind it. That vacuum is strong enough to suck the protective water right out of every trap in the house, leaving every drain open to sewer gas. The solution has been sitting on your roof this whole time. That little pipe sticking out of the shingles isn't a chimney, and it isn't decoration. It's a vent, a straight shot of open air running down into your drain system. As waste falls, air pours in behind it and kills the vacuum before it forms. Cap that vent, leaves, a bird's nest, ice, and every flush becomes a syringe, pulling the traps dry one by one. The first warning is a smell you can't find the source of. Beneath your foundation, the pipe turns, and then it does something that surprises people. It nearly levels out. Building code allows as little as 1/8 of an inch of drop for every foot of pipe. That's almost flat, and it's deliberate. Gravity down here isn't trying to be fast, it's trying to be steady. A consistent, gentle grade keeps water and solids traveling together, foot after foot, all the way to the edge of your property. At the property line, the pipe crosses an invisible boundary. Up to here, every inch of it is yours. Your responsibility, your repair bill. Past it, your flush becomes the city's problem. Under the road runs the main, a larger pipe collecting the laterals of every house on the street. Your flush merges with your neighbors. Drawn on a map, it looks exactly like a river system. Small branches feeding larger ones still, and almost none of it is powered. Engineers design entire neighborhoods around a single requirement: downhill, always downhill. Streets, lots, even the order subdivisions get built in. All of it shaped by the slope of pipes you'll never see. Where the land refuses to cooperate, the city cheats. A lift station. Pumps in an underground chamber raise the sewage to higher ground and hand it straight back to gravity. Depending on your city, your flush may ride this network for miles. Every branch of the river ends at the same place, the treatment plant. First, bar screens rake out everything that should never have been flushed. Wipes, rags, toys. Then grit chambers let sand and gravel settle. Then the primary clarifiers. Vast, slow-moving pools where solids sink and oils rise, and the water in between moves on. Then comes the part no machine can do: aeration basins, pools churning with injected air, where billions of bacteria eat the dissolved waste. The plant doesn't clean the water. The microbes do. The plant just keeps them fed and breathing. Final clarifiers settle the microbes out. Disinfection kills what's left. In a day or two after you press the handle, that water returns to a river, often cleaner than the river it's joining. That's the machine when it works. Here's how it breaks. Tree roots hunt the moisture leaking from an aging lateral's joints. They slip in through gaps thinner than paper, then thicken year after year until the pipe is a solid mat of roots. Grease poured down a kitchen sink cools and hardens like candle wax. And wipes, even the ones labeled flushable, don't break down like paper. They weave together. When the pipe finally blocks, gravity keeps working in the wrong direction. The lowest drain in your house becomes the exit. That's why a failed sewer announces itself in the basement. The early warnings are cheap to catch. Slow drains everywhere at once, gurgling from fixtures you're not using. That smell that comes and goes. A camera inspection costs a few $100s. The version where you find out later costs tens of thousands. The bowl refilled less than a minute after you press the handle. The machine reset, the curve, the stack, the vent, the miles of downhill. You'll trigger it again today without thinking about it. That's the point. The best engineering in your house is the kind you never have to think about. Next, we're x-raying something with worse manners. Why basements flood when it isn't even raining? Subscribe so you don't miss it.